Good afternoon everyone. Welcome to my class. Today I am going to teach one of the important topics, that is nuclear reactions. Almost all the topics in the modern physics. After this one I will teach even radioactivity. These are the few important topics. Definitely they will ask in the exam. Nuclear reactions. What is meant by nuclear reactions? Let us study in detail. What are nuclear reactions? Nuclear reactions are processes in which one or two nuclei are produced from the collision between the two atomic nuclei or one atomic nucleus and a subatomic particles. What is meant by nuclide? Nuclide is a species of an atom with a specific number of protons and neutrons in the nucleus leads a specific mass number. Nuclide already. Nuclear reactions mean nuclear reactions are process in which one or more nuclides. Nuclides means sorry, 1 minute, sorry. Nuclear reactions are process in which one or more nuclides are produced from the collision between the two atomic nuclei. When two atoms collide, when two atoms of nuclei collide, one atomic nucleus and a subatomic particles. You know, subatomic particles are proton, neutron, electrons. When nucleus of two atoms, when they will collide, then we will get the new atom. Okay, when two nuclear fission, nuclear fusion, two types of nuclear reactions are there. In that case, when two atoms, when they will combine, we will get a one type of nuclear reaction. Even when one nucleus of an atom, when you divide, you will get a different type of nuclear atoms. Here nuclear reactions, how it possible, how they will occur when two atoms of nucleus, when they will collide each other. When atoms of nucleus are subatomic particles, when they will collide, then we will get a new nuclides, means we will get a new atoms contain a different nucleus. Nuclide is a species of an atom with a specific number of protons and neutrons. Once the atoms of the nucleus, when they will collide, then we will get the new atom. That new atom, it contains a different number of protons and also neutrons in the nucleus, leads a specific mass number. This one in detail I will explain, then you will come to know in detail. Okay. But in simple words, what is meant by a nuclear reactions, you have to remember like this. When atoms of the nucleus, when they will collide with each other, otherwise they will collide with the subatomic particles, then we will get a new atom of different nucleus. Even proton and neutron numbers are different, because nucleus, it contains proton and also neutrons. Nuclear reactions or nuclear two notable types of nuclear reactions are nuclear fission and also nuclear fusion reaction. The former involves the absorption of neutrons or the relatively light particles by a heavy nucleus, which cause into split into two or more lighter nucleus. What is meant by nuclear fission? Nuclear fission means splitting up of nucleus into two, otherwise splitting up of heavy nucleus into smaller particles, lighter nuclei. What is meant by nuclear fission definition? I am reading here. The former involves the absorption of neutron. It will absorb the neutron or other relatively lighter particles. Nuclear fission, in the case of a nuclear fission, the atoms, otherwise the nucleus of an atom, it will absorb the neutron, otherwise lighter particles by a heavy nucleus, which cause into split into two or more lighter nucleus. Okay, assume you are having big atom having the nucleus. This atom, it will absorb the neutron, then it will split into two atoms, two or more atoms of the lighter nucleus, smaller nucleus. Splitting up of atom of a nucleus into two or three, this one we will call it as a nuclear fission. Fission means, always remember, splitting. Nuclear fusion reactions are the process in which two relatively lighter nuclei combine via collision to offer a single heavier nucleus. In this case, two atoms of the lighter nucleus, they will combine, two or more, then you will get a atom of the heavier nucleus. That one only here, heavier nucleus. Nuclear fission means splitting up of heavy nucleus into smaller nucleus of an atom. Nuclear fusion means two lighter nuclei combines to form a atom of a heavier nucleus. Okay, let us discuss in detail. I will explain in detail what is meant by nuclear fission fusion reaction. Then why these nuclear reactions, why they will occur, everything we will learn in detail here. Why do nuclear reaction release tremendous amount of energy? Whether it is a fusion or fusion, both the reaction, nuclear fusion or fusion, both the reaction, they will release tremendous amount of energy. Why they will release the energy? Let us discuss. The mass of an atomic nucleus is always less than the sum of the individual masses of each subatomic particles that constitute it, protons and also neutrons. Yes, the mass of atomic nucleus, the mass of the nucleus, it will be always less than the sum of the individual masses of each atomic particles, that everyone will know. The difference in masses is attributed to the nuclear binding energy, often referred to as a mass defect. Nuclear binding energy. Okay, what is meant by nuclear binding energy? Then defined as the energy required to hold all the protons and neutrons inside the nucleus. Inside the nucleus we are having proton and neutron. These proton and neutrons, proton are positive charge, neutron it does not contain any charge. Then here this nuclear binding energy, that it will make proton and neutron together inside the nucleus. Don't get confused. Nuclear binding energy means inside the nucleus it will exist. It make that energy, it will make proton and neutron, they have to together inside the nucleus. Okay, why nuclear reaction, they will release tremendous amount of energy? Because the mass of atomic nucleus, this mass of atomic nucleus is always less than the sum of the individual masses, okay, of each subatomic particles that constitutes, that is either proton or neutron. That difference in mass, it will produce a nuclear binding energy. Next one, again same, that one. During a nuclear reaction such as a fission or fusion reaction, the mass accompanied by the nuclear binding energy is released in accordance with the equation E is equal to mc square. Even small e or capital E you can use. E, it will be equal to mc square. E energy, it will be mass, how much energy is released, that much mass times the square of the speed of the light. How much energy it will released in the nuclear fission or fusion reaction, it will be equal to E is equal to mc square. To simplify, the product formed in nuclear fission and fusion reaction always have a lower mass than the reactant. Yes, whatever the product you will get, always that product, the mass of that product is always less than the reactant. The product formed in nuclear fission or fusion, the product we will get in the case of a nuclear fission or fusion, then that product, it has a less mass compared to the mass of the reactant. That one you have to remember. Then here you can see the difference. The product mass, it will be, the product formed in nuclear fission or nuclear fission have a lower mass than the reactant. Here reactant mass, it will be more, reactant mass, it will be more than the product mass. In the case of whether it is a nuclear fission or fusion, this extra, otherwise this difference in mass, otherwise missing mass, is converted into a energy. Simple word. In the case of a nuclear fission and fusion reaction, why enormous amount of energy, why it will be released? This is the correct answer. You can give this point as an answer, because the mass of the reactant, it will be more than the mass of the product. Otherwise, whatever the mass, whatever the product you will get, the mass of the product is less than the mass of the reactant. Both the way also you can see. Then that missing mass, it will be converted into a energy. A single gram of matter can release approximately, see how much energy it will be released in kilojoules. This much kilojoule. A gram of, a single gram, 1 gram, 1 gram of matter, any matter you consider, 1 gram of matter, it will release this much kilojoules of energy. Understood? Whatever the product you will get in the nuclear fission or fusion reaction, the product mass, it will be less than the reactant mass. Then missing mass is converted into an energy. How much energy? Here I included the example. 1 gram of matter can release approximately this much of kg. How many zeros? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 9 into 10 to the power of 10 kilojoule of energy. Let us discuss in detail what is meant by nuclear fission. Nuclear fission refers to the splitting up of atomic nucleus into two or lighter nuclei. Heavier nucleus you can consider. Fission means, when you see the word fission means, in your mind you have to think fission means splitting up of an atom, atomic nucleus. Here, splitting up of an atomic nucleus into 2 or 3 lighter nucleus. You are having the bigger nucleus of an atom, it will be split into 2 lighter nucleus. This process can occur through a nuclear reaction or through radioactivity decay. You can observe this change in the radioactivity decay. Nuclear fission reaction often release a large amount of energy, which is accompanied by the emission of neutron. Yes, in the case of nuclear fission, which subatomic particles it will release? Neutron will release, and gamma rays, photon holding huge amount of energy, enough to knock electron out of atom. It is that energy is sufficient to kick the electron from the atom, otherwise remove the electron from the atom. See here, uranium 235. Here you can observe nuclear fission. This is the huge nuclear atom, uranium 235 92. And also here this uranium 235, it will split into barium and also krypton. Then it will release the neutron. You can observe emission of neutron, it will take place, emission of neutron. Okay, here barium you will get, krypton you will get, split into 2 lighter nuclei. Understood what is meant by nuclear fission? Splitting up of an heavy atomic nuclei into 2 or 3 smaller atomic nuclei. Understood? Next, nuclear fission was first discovered by the German chemist Otto Hahn and Fritz Strassmann in the year 1938. Remember the scientist name. The energy produced from fission reaction is converted into electricity in nuclear power plants. Yes, in the case of a nuclear fission, here also we will get enormous amount of energy. Then this energy we will use to convert, we will use in electricity in the, to generate electricity we will use in the nuclear power plants. This is done by using the heat produced from the nuclear reactions to convert water into a steam. Here this fission reaction we will use to generate an electricity. Then here once you get the heat, then that heat it will convert water into a steam. The steam is used to rotate turbine in order to generate the electricity. Then that steam, if you pass through the turbine it will be continuously, it will be rotating, it will generate an electricity. Example, here I included one more example, that uranium one only. I explained in detail step by step. You can go through that one. An important example of nuclear fission is the splitting up of uranium-235 nucleus when it is bombarded with neutron. Here you can see when you will bombard uranium with neutron. Here see, bombard means you have to hit each other. Various products can be formed from this nuclear reaction as described in the equation below. Yes, here you can follow the steps how the splitting up of heavy nucleus into smaller nucleus it will takes place. Next one, this is the very small topic, within half an hour I can complete. Okay, nuclear fusion. In nuclear fusion reaction, at least two atomic nuclei combine or fuse into a single nucleus. Subatomic particles such as neutron, proton are also formed as the product of in this nuclear reaction. See here, deuterium and tritium, two nuclei, when they will combine, enormous amount of energy it will release. Then we will get here helium and also neutron. Here also neutron it will produce. An illustration of the nuclear reaction, fusion reaction between deuterium and tritium, okay, that yield helium and also neutron. When two or more lighter nuclei fusion means combine, we will get the bigger one. Such fusion reaction occur at the core of the sun and other stars. They may ask in the exam, this nuclear fission reaction in the nature where it will occur inside the core of the sun and also star. The fusion of deuterium and tritium nuclei is accompanied by a loss of approximately 0.0188 AMU, means atomic mass unit of mass, which is completely converted into a energy. Yes, in the case of why nuclear fission and fusion reaction, the mass of the reactant it will be less than the mass of the product, where extra mass, that loss of mass, where it will go, it will be converted into an energy. See how much mass it will lost here. The fusion of deuterium and tritium nuclei is accompanied by a loss of approximately 0.01188 AMU. This mass it will be converted into an energy. Approximately 1.69 into 10 to the power of 9 kilojoule of energy are generated for every 1 mole of helium formed. When 1 mole of helium formed, then how much amount of energy it will released? 1.69 into 10 to the power of 9 into this one. Okay, this point is very important, what I am explained in the last slide. See, whatever the reactant mass, it will be more compared to the mass of the product. That lost mass, it will be, otherwise missing mass or lost mass, missing mass it will be converted into an energy. That one you have to remember. Okay, this topic is very easy. Then last one, let us discuss in detail what is the difference between nuclear fission and nuclear fusion reaction. Nuclear fission is a nuclear reaction that split a heavy atoms into two or more smaller ones. Fission, splitting. Nuclear fusion is a nuclear reaction that combine two or more small atoms to form a larger atoms. Then nuclear fission, it does not occur naturally. We can't see any fission it will occur naturally, but fusion it will occur. The universe is full of instances of nuclear fusion reaction. Every star use it to produce energy. Even sun also, inside the core of the sun also nuclear fission reaction it will produce. Then nuclear fission, it produces a large quantity of energy But in the case of fusion, it produces greater energy than the fission reaction. This is very, very important. In the case of a nuclear fusion, that energy, whatever the energy we will get, that is more than the energy produced by the nuclear fission reaction. Does not require a lot of energy split an atom into two. It does not require that much of energy to split an atom. Easily you can split an atoms. Okay. It require a lot of heat and pressure for the process to happen. But fusion, you are making two or three atoms to combine, two or three nucleus of an atoms to combine. Combination, otherwise you are making the atom to combine, it needs more heat and also pressure. Very easy topic, only within 20-25 minutes I can complete this one. Then next one, application of nuclear fission, where we will apply this one. We are still at an experimental stage as far as nuclear fusion reactions are considered. Clean, no combustion occurs in nuclear power, fission and fusion. So there is no air pollution, whether it may be nuclear fission or fusion, we will not get any air pollution. Less nuclear waste. Fusion reaction will not produce high level nuclear waste like their fission counterparts, so that disposal will be less of a problem. In addition, the waste will not be of weapon grade nuclear materials as they in the case of a fission reaction. Here, less nuclear waste. In the case of a nuclear, one more time I will read. The fusion reaction will not produce high level nuclear waste like fission. Fusion, it will not produce that much of waste. But fission, when it will splitting the nucleus into two or three, no, it will produce little number of nuclear waste in the case of a fission. But in the case of a fusion, this also produce, but this it will produce fusion, it will produce less number of, otherwise less amount of nuclear waste compared to the fission. Okay. In addition, the waste will not be of weapons grade nuclear materials as in the case of fission reaction. Okay. Last one, nuclear fission is used to produce some less gamma radioisotopes like cesium 135 by using uranium 235, which is used in photographic source, where we will use these two. Nuclear fission energy is also used as a power source for propelling submarines, some type of surface vessels. Okay, these are the, today I explained in detail what is meant by this nuclear reactions. Two types of nuclear reactions are there, nuclear fission and nuclear fusion reaction. Then we studied their difference and also we studied their application, everything in detail. This almost I took only 20 minutes, small topic, no? And then next topic I will take radioactivity, that is the very interesting and also very important topic that I will teach tomorrow. I have to create everything. I have to make a slide properly. Then tomorrow I will start the next one, that is radioactivity. Okay. Okay. Thank you everyone. Thanks for watching my class. Please, when you are having free time, please watch my class. Okay.